Hi everyone, let's take a look at number 25 on page 420. Determine the angle that the vector A equal to 12, negative 3, and 4 makes with the y-axis. Now there are two ways of doing this. So in the first part of this video, I'll call this method number 1. And in case you want to move on to method number 2, feel free to go to the bottom in the description and just hit method number 2 in terms of the timer. Now, method number 2 is a shortcut, by the way, called directional cosines. And method number 1 is I don't know any formulas except for the dot product. Can I use the basics? And the answer is yes. And before I even write down the dot product formula, you want to think about what this looks like. So again, I'm going to give you a little bit more in terms of what you're looking at, and then we'll go straight to the math. So if you think about the vector 12, negative 3, 4, what that really means is if I'm sketching this out, and again, some students find this so meaningful, the fact that they can see this, right? So 12 means on the x-axis, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Then on the y-axis, you're going to go negative 3, right? So you're moving in the negative direction 3 times. And again, I'm not using perfectly straight lines, but I hope you understand what I'm doing here. And on the z-axis, I'm going to go straight up by 4. So again, in case you're thinking, what does this even mean? How do I trace this? First, you're going in the positive direction 12 times. Then you're forming this parallelogram that I've talked about in a separate video. You can always go back and watch it. Then you're going to go up by 4. And to do that, you're forming this box. I call this a shoebox. It could be any box really. So again, what you're thinking is this. You go 12 in the positive direction on the x-axis, 3 in the negative direction on the y-axis, and 4 in the positive direction on the z-axis. And of course, this is z. Let's write down z. And if I use a different color, I'm saying to you that this vector right here in green is going to be vector A, which is going to be 12, negative 3, and 4. Now, why is this so useful? It's because now you can say, oh, I'm looking at this with respect to the y-axis. Now, this is where it gets a little bit confusing because is it going to be the acute angle? Is it going to be the obtuse angle? How do we know? So right now, I'm going to give you this measurement, this angle theta, which is going to be the obtuse angle. And of course, you could always say 180 minus theta, which will give you the acute angle, because if you really think about the y-axis, we're assuming we're looking at the positive part of the y-axis, but really you could argue, well, what about this angle? Isn't this the other angle that I'm thinking about? So again, we'll stick to theta for now. And here we go. So method number 1 simply means you can apply the dot product. And of course, dot product means vector A dotted to vector B equals to the magnitude of A times the magnitude of B, cosine the angle between them. And since you're looking for the angle, cosine theta is going to be the dot product of vectors A and B divided by the magnitudes, just like that. So in this case, basically, cosine theta equals to, again, think about vector A. That's going to be 12, negative 3, and 4. And if you think about the y-axis, which I'll highlight using a different color here, you can pick one possible vector. So I'm going to pick 0, 1, 0 just because it will be something like this if you go right by 1 unit. Now, of course, you don't have to pick this number, right? You could pick any other vector that presents the y-axis. But again, 0, 1, 0 is just one of the many examples. And you divide this by the magnitude. So you take the square root of the sum of the squares, 12 square plus negative 3 square plus 4 square. And in the second case, this really equals to 1. It's going to be 0 square plus 1 square plus 0 square. Again, assuming for you, just like that. And now, if I copy cosine theta, on the right, 12 times 0 is going to be 0. Negative 3 times 1 is negative 3. 4 times 0 is going to be 0. If I look at the denominator, again, I can take my calculator. I'm going to work it out. So if I take 12 squared, that's 144, plus 9, plus 16, that's going to be 169. So theta is going to be the inverse cosine. And again, make sure the calculator, turn it on, press clear, make sure in degree mode. of negative 3 divided by 13. Now, if you round the answer to the nearest degree, this is going to be inverse cosine of negative 3 divided by 13, which is approximately 103 degrees. So again, this is the obtuse angle. Now again, just in case you're thinking, well, what about the acute angle? You can always take 180 minus theta, which is going to be 77 degrees. That's the acute angle, just like that. Now, here comes method number 2. Let's go back. We're going to redo this whole question again. So let me just erase this for you, and we'll go straight into it. Here we go. Now, method number 2 is going to be a lot faster because you can apply this concept called directional cosines. And directional cosines is basically a formula that you can use in terms of calculating the angle with respect to the x-axis, the y-axis, or the z-axis. So method number 2, I'm still going to set up the same diagram, so that doesn't really make a difference. The only difference is the formula. So again, this is called directional cosines. Let's write this down. Now, there are 3 formulas when it comes to directional cosines. The one we're thinking about is the one with respect to the y-axis. So cosine beta equals to b divided by the square root of a squared plus b squared plus c squared. So in this case, when you apply this formula, cosine beta is going to be b, which is negative 3. So again, in case you forgot what that means, let's go back. We know we're given the vector 12, negative 3, and 4. So these values, 12, negative 3, and 4, are the values of a, b, and c respectively. So that's why b is going to be negative 3, divided by the square root of 12 squared plus negative 3 squared plus 4 squared. And again, we just did this, right? It's the same thing. Let's zoom in for you. Again, if you solve for the right-hand side, that's going to be negative 3. 12 squared plus 9 plus 16, that's going to be 169. Take the square root, that's going to be 13. Again, if you take the inverse cosine and you round this to the nearest angle or the nearest degree, it's going to be approximately 103 degrees. If you're looking for the acute angle, and again, it really depends on the question, right? You take 180 minus 103, that's going to be 77 degrees, which is the acute angle. Or the obtuse angle is going to be 103 degrees. I hope this makes sense.